This video is going to look at how we can solve a right triangle for missing sides using our trig functions. So the first example we have here, and for the first several triangles, it says we want to find the values of x and r. So we have a right triangle, we have a 30-degree angle, we have the side next to it is x, the side opposite is 30 degrees, and we have the hypotenuse is r. Now we can use a trig function to solve for x and r. And at this point, it really doesn't matter which one we solve for first, but I'm going to go ahead and solve for x. And if we're going to use a trig function to solve for x, if we're looking at the 30-degree angle here, then we know that x is the adjacent side, and the 30 over here would be the opposite, and the r would be the hypotenuse. So if we're going to solve for x, then if we think of our trig functions, normally we're either looking at x and y are opposite and adjacent. There's basically three parts to our trig function. We have the angle, and then we have the ratio of whether it's the opposite over hypotenuse or adjacent over hypotenuse or opposite over adjacent. And we need to know two of those in order to solve for the third piece. So which of our trig functions, if we use the 30-degree angle, what trig function deals with adjacent, which is what we're looking for, and the opposite side? And if we think about that, that would be the tangent. So if we were to take the tangent of theta, we know that is opposite over adjacent. So that means we could substitute in the tangent of the angle 30 degrees is equal to the opposite side of 30, and the adjacent side is the x that we're looking for. So now we need to simply solve this equation for x. Well, because the x is on the bottom at this point, to get x off the bottom, we could multiply both sides of the equation by x, and we would be left with x multiplied by the tangent of 30 degrees is equal to 30. Now at this point we could actually take the tangent of 30 and come up with a number, but here I want to get x by itself first, and since this is multiplication, we can simply divide both sides of the equation by the tangent of 30 degrees. And once again here the tangents would cancel out, and we're left with x equals 30 divided by the tangent of 30. So we could go to the calculator and we would type in 30, and once again I'm going to go to the mode. Make sure you go to your mode. It is in degree mode. Okay, so then we would take 30 divided by, and we said here that's the tangent of 30, and we get 51.96. So I'm just going to actually round that up and make it 52. So x is equal to 52. Okay, so now all we have left is to solve for r. Now, we could certainly use the Pythagorean theorem now, because we could take 52 squared plus 30 squared is equal to r squared. Now, instead of doing that, I want to continue to use our trig functions just to give you some practice. So if we didn't know the value of x, then which one of our trig functions has the opposite and hypotenuse? And that would be our sine function. Sine of theta is equal to opposite over hypotenuse. So therefore we could take the sine of 30 degrees, the opposite is 30, and the hypotenuse is r, is which we're looking for. And once again, to get the r off of the bottom, we could simply multiply both sides by r. And again here the r's would cancel out. So we would end up with r sine of 30 degrees is equal to 30. And then again, I would go ahead and divide to cancel out the sine of 30 so that we can get r by itself. So we would get r equals, again, sine 30 cancels. So again, we can go to the calculator, 30 over the sine of 30. We could certainly just type in 30 divided by the sine of 30 degrees, and we get an answer of 60. So there we have solved for x and we solved for r. And we can actually double check this. Now because we rounded, it's not going to come out exactly, but if we try the Pythagorean theorem of 52 squared plus 30 squared, does that equal 60 squared? So if we take 52 squared plus 30 squared, okay, now is that equal to 60 squared? Okay, so that is fairly close. And again, we're off a little bit because of the 52. Remember here, the 52, I rounded this decimal. If I'd have carried this out further, this would have came out to equal a little bit closer. So therefore, we have solved for x and r. All right, now I do want to point out for this problem, I wanted to look at using our trig function. There is an alternative method here that we could have used, and this requires a little bit of knowledge of this particular triangle where we have a 30-degree angle. Let's see, this is x, this is r, this is 30. And let's see if we can work this out slightly different. And again, like I said, this is the same problem, just an alternate technique where we would have to realize and recall in a previous video I talked about a 30, 60, 90, because we know if this is 30, this angle has to be 60. The side opposite of 30 is x, opposite of the 90-degree angle would be twice as big, and opposite of the 60 is x multiplied by the square root of 3. So if we applied this special 30, 60, 90 triangle, then we know here the opposite side here of the 30-degree angle is actually 30. Then that would tell us that r is twice as big. So that would tell us that this would have to be 2x, which would be 2 times 30, which would be equal to 60. And then if we're going to calculate the value of x, then that means we're going to take x, which is the 30, and multiply that by the square root of 3. So therefore we would have 30 multiplied by the square root of 3. And let's see what we come up with here. We would take 30 multiplied by the square root of 3. And once again, we get 51.96, and so therefore that would round up to 52. So we come up with the exact same answer. So if we remember the 30, 60, 90 triangle, that's really easy, but this only works again if you have a 30, 60, 90 triangle. But for this particular problem, I really wanted you to get to see the idea of how we can use our trig function, in this case the tangent and sine. All right, the next example, we still have a 30, 60, 90 triangle. Now again, we could still use the same idea of this special 30, 60, 90, but again, I want to practice using our trig functions. So once again here, if we're trying to find the value of x down here, then we have a 60-degree angle, and then we have this side. So we have the angle and we have the two sides. Now what two sides do we have? Well, we have the opposite and we have the adjacent. Or we have the opposite and we're looking for the adjacent. So therefore, we could use the tangent. So that means, again, we could take the tangent of 60 degrees is equal to the opposite, which is 32, over the adjacent, which is x. And then, of course, we want to solve for x. So you're just going to use basic algebra skills, and we're going to multiply by x. The x's will then cancel out. So we would have x multiplied by the tangent of 60 degrees is equal to 32. And then once again here we can divide by the tangent of 60 degrees. And that way we can solve for the value of x. So we would take 32 divided by the tangent of 60. And we could go to the unit circle because 60 degrees is there and we could actually find the exact answer. But here it's going to be a lot easier just to take 32 divided by the tangent of 60 degrees. And here we get 18.475. And this time I'll go ahead and go out a couple places. So let's make it 18.48. Okay. And then once again here, if we're going to solve for r, we now are looking at using the opposite side and the hypotenuse. Now we found the adjacent side, so we could use the adjacent side and the hypotenuse, but if the better option would be to use the opposite because the 32 was given. So therefore, if we made a mistake calculating the value of x, then if we did that, then we know if we calculate r, we're going to miss that as well. So usually, if possible, you want to use the given information. So in this case, we're going to use the opposite side to find the hypotenuse. So the trig function that deals with opposite and hypotenuse would be our sine function, okay? So the sine of 60 degrees is equal to the opposite, which is 32, over hypotenuse, which is r. And we would simply multiply again both sides by r. In that case, we get r sine of 60 is equal to 32. And then we would divide by the sine of 60, so we would get r is equal to 32 over the sine of 60 degrees. And going to the calculator, we would take 32 divided by the sine of 60, and we get 36.95. Okay. Now, the next example, we want to find the values of x and r, and this time we have a 45-degree angle. And once again, we would basically kind of go through the similar type process. If we're going to look for the x, well, for the 45 here, this would be the adjacent side, and again, the 20 is the opposite. So the trig function that deals with that would be the tangent. So we could certainly take the tangent of 45 degrees, and we know that's going to be equal to the opposite, which is 20, over the adjacent, which is x. And once again here we would multiply both sides of the equation by x, and therefore we get x tangent 45 degrees is equal to 20, and then we want to divide away the tangent, so x is going to be 20 divided by the tangent of 45 degrees. So therefore, if we enter this into the calculator, we take 20 divided by the tangent of 45, and we get an answer of 20. Now at this point, I don't know if you're surprised or not, because if we looked at this, we know that the angle up here at the top is also 45 degrees, so that tells us the two sides have to be the same, so therefore this is also 20. So you really could have found this adjacent side, the value of x, by simply saying, oh, it's a 45, 45, 90, so therefore this is 20, this other side has to be 20. And then, of course, you could use the Pythagorean theorem to find the hypotenuse, 20 squared plus 20 squared. So in this case, that's probably the option you could use. Or, once again, we could simply use what trig function? Well, if we use the 45-degree angle, we have the opposite, we have the hypotenuse that we're looking for, so that would certainly be the sine. So we would take the sine of 45 degrees, opposite is 20, and the hypotenuse is r, and once again to solve for r, we want to get it off of the denominator, so we're going to multiply both sides by r, and we certainly end up with r sine of 45 degrees equals 20. Divide the sine away, so r is equal to 20 over the sine of 45 degrees. So if we go to the calculator, we can take 20 divided by the sine of 45, and we get 28.28. Okay. Now, if you recall, earlier when we had a 30, 60, 90 triangle up here, we said this had a special x, 2x, and x squared of 3. And if you can remember back, we did mention there is a special formula when we have a 45, 45, 90, and that is the two sides are the same, and the hypotenuse is simply x multiplied by the square root of 2. So if we apply that to our given problem, then that would tell us that the hypotenuse would have to be the value of x here multiplied by the square root of 2. Well, the value of x that we had up here is the 20. So what if we take then 20 and multiply that by the square root of 2? Well, we take 20 multiplied by the square root of 2, and we get 28.28, which is exactly what we have here above when we plugged in evaluating the sine of 45 and then dividing that into the 20. So 28.28 is the same answer. So always with math, there's more than one way that we can solve the problem. Again, the main idea for this one was, again, experimenting with your tangent and sine function to solve the right triangle. All right, we have one more example here to look at, and this is a word problem. It says that you are standing 45 meters from the base of the Empire State Building. You estimate the angle of elevation. All right, now the angle of elevation, that means when you're standing here at the bottom, if this is, you're down here standing, and when it says angle of elevation, then that means as far as this angle that you're looking up this way towards the building. So if over here we have, this is the Empire State Building, then the angle of elevation here is the angle that you're looking up off of the ground. So it says that you estimate the angle of elevation all the way up to the 86th floor, which is the observatory, to be 82 degrees. So we're saying that this angle here that you're looking up from is an angle of 82 degrees. And one of your friends is on the 86th floor, and the question is, what is the distance between you and your friend? Well, that means we're actually looking for this distance here. So we have a right triangle with the building, so how can we determine what is this particular distance going to be? Well, it also tells us that we're standing 45 meters from the base. So that tells us that down here at the bottom, we are 45 meters away from the base of the building. So now we have two pieces of information. We have the angle, and if we think about this problem here, we have the angle and we have the adjacent side, and we want to look for the hypotenuse. So which of our trig functions deals with adjacent and hypotenuse? Well, that would be the cosine. The cosine of theta. Okay, again, if you think of that phrase I told you, SOHCAHTOA, cosine is adjacent over hypotenuse. So we would take the cosine of the 82-degree angle is equal to the adjacent side, which is 45 over the hypotenuse, which is the distance we're looking for. And once again, to get the variable off of the bottom, we're going to multiply both sides by r. And we would get r cosine 82 degrees is equal to 45. So that means we would take r is equal to 45 divided by the cosine of our 82-degree angle. And if we go to the calculator, 45 divided by the cosine of 82, we get 323.33. So in this point, I'm just going to round this to 323. So this would be 323. Now, because this was a word problem, we should have units here. What is this distance? Well, it's 323, but we said that this is down here 45 meters. So therefore, this must be 323 meters from you to your friend on the 82nd, on the 86th floor here of the Empire State Building. So hopefully now you have the hang of how we can solve a right triangle using either your sine, cosine, or tangent, and it's all based on which side do you know? Do you know the adjacent, the hypotenuse, or the opposite side? So as long as you know one of those sides and the angle, you can always find the missing side.